Hi, my name is Mihai Aldea. I'm a product manager at Rohde and Schwarz, and today it is with great pleasure to show you a test setup where the REG800A is the core element. Here the REG800A is the back end of this test system, and we use this instrument to generate the targets for the radar under test. From the front-end perspective, we use the REG881S, which is a monostatic millimeter wave front-end using a single antenna and being therefore suitable for testing MIMO radars. And talking about MIMO radars, I would like to mention that from the DUT perspective, here we use the Pluto radar sensor from NXP, which has the newest chipset from NXP, and it's actually the first 28 nanometer RFCMOS radar. We also have a shielding system, we call it QATZ50, and here we see another box, which is the FMCW200A, our signal generator that we use for interference testing. Now I would like to talk a bit about the minimum distance that can be simulated using the REG800A. And you know, before we were talking about 17 meters, after that about 4 meters, then about 2 meters. But this was always a boundary because the short-range radars require extremely short distances to be simulated. And as this was a boundary so far, I would like now to kindly invite you to break this boundary, because now I'm going to launch actually a new feature for the REG800A. It's a software feature, we call it K814 or Near Object Range for FMCW radars. This is a unique feature and it's patented by Rohde and Schwarz. And using this feature, we are actually able now to reduce the distance of an artificial object down to the air gap value of the radar under test, which in this configuration it's actually 0.5 meter. And here we see I generated 8 targets using only one channel in the REG800A. 3 of the targets have 0.5 meter distance, and all the targets have short distances because all of them are below 1 meter. I can of course put all the targets at 0.5 meter because I would like to highlight the fact that all the generated targets can have extremely short distances. And I was mentioning before interference testing. So now I will start the measurement, and I will use the SMW200A to create an interference signal, and I will superimpose that signal onto the target signal. So let's see what will happen. And as you can see, now the radar under test is not anymore able to perceive the targets in presence of strong interference. And I would say that now this could be a good moment for the radar developers to come and play their interference mitigation algorithms and to recover the targets from the noise. Now I will stop the interference so that we can see the targets again. And this was Mihai from Rohde and Schwarz. And if you want to know more, then just please visit us at rohde-schwarz.com.